Hey guys, thanks for taking the time out today to learn a bit about electric bikes. I'm a total nerd about this subject, so I could talk for hours, but I'll try and make this quick. We've seen a lot of crazy stuff in this industry and some dangerous mistakes actually. I want to make sure that you don't make the same mistakes that we've seen other people make. And full disclosure, I do own this company, FLX Electric Bikes. We started this in 2015 and here we are now. So welcome to the shop, and let me teach you a few things about electric bikes, especially if this is kind of your first time encountering them. I'm gonna show you 5 things that you need to know, 5 questions you need to ask before buying your electric bike. Question number 1 that you need to ask before getting an electric bike is, what kind of motor does it have? Is it a hub motor or a mid motor? So let me show you what that means. A mid motor is right in the middle of the bike. That's why they call it a mid motor. Now the advantage of that is that the mid motor is before the bike's gears. Typically you'll see a cassette in back and probably a single gear in the front. So what that means is, I'll turn this bike on real quick so you can see. And I'm just gonna hit the throttle here so you can see the motor moving. Now the motor's here and it's driving this chain, and after that in line, you got the cassette. So if I wanna go up a hill and get the maximum amount of torque and hill climbing power, I wanna be in the smallest gear. And the motor can utilize that gear to get up the hill with the most amount of torque possible. Now let's say I get up the hill and I want to go on a flat and I want some speed. Now I'm going to shift the bike, and this is the same throttle power, but now I'm going way faster. So the bike's now taking advantage of this gear to get the most amount of speed. So if you've driven a stick shift car, a motorcycle, anything like that, where you have to manually shift gears, you know, you go 1, 2, 3, 4, 5, you shift down to go up a hill, exactly like this bike. When you want to go up a hill, you shift down, and the motor can use those gears to multiply its effort and get up that hill or to hit higher top speeds. So that's a huge advantage of this mid motor. You get much better performance from even the same power motor. Now, you'll see a lot of electric bikes. It's very common to have a motor back here in the rear wheel, and that also has its advantages. The main thing being cost. So those are a lot cheaper to make, a lot simpler and easier to manufacture on a bike. So for example, I'll just divulge our costs on this. We're paying about 500 bucks for these motors alone here. A hub motor, you can get those for $60, $70, pretty crazy. Similar power rating. This costs about 10 times more, and there's a reason, even though that costs a lot more, that we use this. It's because of the increased performance. So the hub motor does not have the gearing advantages. It's after the cassette in the powertrain, so you won't be able to climb hills or go to top speeds as efficiently as a mid motor. It is cheaper, and that's about the only advantage to the hub motor. Cheaper, simpler, you'll see them, they're a lot more common. The other thing that you should consider with the mid motor versus hub motor is the weight balance. So right here with the mid motor, I've got the weight in the middle of the bike. It's very balanced. With the hub motor, you'll have 5 to 10 pounds, probably closer to 10 pounds back here in the rear. So it will be like this. You have all the weight back here. If you're going off curbs and stuff, it'll feel kind of goofy. All right, so as a bonus question here, this is not one of the 5, but a bonus question here to know if whoever you're talking to about electric bikes really knows their stuff. Ask them if the motor is a torque sensing or cadence sensing motor. And let me tell you what that means. So the motor itself, typically for e-bikes, it works this way. You press on the pedals, and then the motor goes. But there's 2 ways in general for the motor doing that. One is called a cadence sensor, and that's really simple. Basically, the motor is measuring, are the pedals turning? And if the answer is yes, okay, motor goes. So our original first generation of this bike was a cadence sensing motor, and basically you press on the pedals and the motor goes. So that's cool, but you only pretty much have one level of motor power. If you're, say, trying to navigate a parking lot, just turn around or kind of navigate a tight hill on a trail, and you press the pedals, you'll get all the motor power from that. That's a cadence sensing motor. There's not a lot of control on that. The advantage of a cadence sensor is typically they are cheaper and simpler than a torque sensing motor. Now this is a torque sensing motor, and how that works is it senses how hard you press on the pedals. I'll try and give you an example here. It measures how hard you press on these pedals, and it's going to give you an equivalent amount of power. So right now I'm turning these, and the motor's not even really kicking on at all. So I could be navigating really slow speed in a parking lot, trying to get around some young children or something without hitting them. Now if I want the power, I press hard on it, and you hear the motor go. See how much power just came out? I pressed hard, and it goes. So torque sensing will give you a really natural feel to the ride. If you want it to feel just like you're riding a normal bike, but you've got a lot more power in your legs, kind of like Superman, a torque sensor is probably the way to go. If you're looking for a more budget option, again, cadence sensor is still fun to ride. So that's your bonus question for the motor. So another advantage to the mid motor versus hub motor is you've got a standard setup here in the back with the mid motor. So if you look at the back here, this is exactly like any performance regular pedal bicycle you would see. We've got the disc brake, the gears, and a through axle here. I'll get more on that later. But if I were to do something stupid, which I often do, I'll admit, and I pop this tire, maybe I jumped a curb too hard, didn't inflate the tires, hit a nail. If I wanted to take this wheel off, it's super easy. I just do this, unscrew it, and pull the wheel off. I'll show you how to do that later, but swap it off. I could change the tire. Maybe I want to throw the bike in my car, pull the tire off, and it will fit in the trunk. That's super cool. Now with a hub motor, you will not be able to do that. The reason is the electronics, the motor is all back here, and you've got wires trying to power this motor. We'll throw a picture of that up. So if you get a flat tire, if you want to change, just pull the wheel off, it's a complete pain in the ass. Pardon my language, but that's our experience with it. So when we initially started this company, we were trying to provide the most cost-effective bikes, performance bikes we could to people. And we looked all over, we tried all different kinds of motors. We tried hub motors, we tried mid motors, and it would have been way easier to go with a hub motor because it's way less expensive, but we just couldn't do it. We wanted the performance. We didn't want to settle for second best. It had to be a mid motor. That's why we made that choice. If you're looking just for something casual on a budget, maybe a hub motor is good for you. If you want the performance, kind of the best you can get, a mid motor is probably more along the lines of what you're looking for. So question number 2 you need to ask before getting an e-bike is how much power does the bike have, and does that fit the kind of riding that I want to be doing? So there's a big misconception here that I need to tell you about before you get it, because we see it all the time. And to kind of explain that, I'm going to ask you a question, and it's kind of a riddle, so hang with me. If I want to take a bath, of course I want to take a nice warm bath, and the bathtub is half full, do you think I would get it warmer faster if I added water at 100 degrees or if I added water at 200 degrees? Which one would make that bath water warm up faster? Take a second and think about it. All right, I know you probably answered 200 degrees, and that's what most rational people would say. But unfortunately, you've only had half of the information you need to answer that question, because I didn't tell you that I've only got one small drop of water at 200 degrees, and I've got a whole truckload of water at 100 degrees. So obviously if I add only one drop of water at 200 degrees, that bath water is not gonna heat up probably at all. So You know how hot the water is, but not how much water there is. And how that relates to e-bikes is when it comes down to volts. You'll hear this bike is 36 volts, or this one's 24, this one's 72. And a lot of people, especially that are new to e-bikes, think, oh, well, 72 must be twice as powerful as 36. But what they didn't tell you is what current, how much electricity is coming through that motor at one time. You could have a 36 volt motor and a 72 volt motor with exactly the same power. The 72 volt is twice the electricity, but it could be half the current. So let me show the equation to calculate that out. Power, like I just said, does not equal volts. Power equals watts, which is volts times current, V times I, if you're a math geek like me. So you need to know both the volts and the current to get that. So just to simplify that, you can always go with the watt number to know the actual power of the bike. So don't base it off of volts, don't base it off of current alone. It's gotta be off of watts to know the power. Now, what does that mean to you? To put that in reference, our most popular bikes, the Roadster and the Trail, those have motors that operate at 500 watts. Now that's 500 watt nominal power, so that means it can run continuously at 500 watts, and it also peaks at 850 watts power. So for example, if you're trying to climb up a hill or just sprint, get a burst of power, it will go over that 500 watts up to 850 to provide you that momentary power to, conquer an obstacle, a hill, or something like that. So to put that in perspective, follow me over here. You see TC, that's your typical cyclist. So everyday guys out there riding their bikes, kind of average fitness level. If they're at a quick pace, they're operating at 100 to 150 watts of power. Now, I just told you that these bikes have got 500 watts of nominal power. So right away, just from the motor alone, you've got 3 times as much power as a typical cyclist. And the cool thing about that is you also have your own pedal power. So you've got 500 watts plus your own pedal power, and you can just cruise. It's quite an incredible experience. You really feel like Superman when you add that much power to your own pedal power. Now, let me put that even further into perspective. The current record holder for the most amount of power in 1 hour is a guy named Bradley Wiggins. Now, Bradley Wiggins was the 2012 Tour de France winner, and for 1 hour he cycled and averaged 410 watts of power. So right away with our basic models, the Roadster and Trail, you're already past Tour de France level. You could be a Tour de France world record holder in terms of the amount of power that your bike is outputting. Add that to your own power and the experience is just incredible. So I know that's kind of a lot of information to take in. The question is, how much power does the bike have? And I've got to follow that up with another important question. This is kind of a bonus question for you, is you need to ask, what is the model of the motor? And the reason I say that, unfortunately, is this is kind of a newer industry, so there's some shady stuff going on where people will overstate the motor power. They'll take a 250 watt motor and say, hey, this is 750 watts, or this is 1,000 watts. So if you want to do your own due diligence, you can ask what is the model of the motor. You can actually look at it yourself, kind of read the model numbers, and then do some research online. And at the very least, look up that motor and see what the manufacturers claim the power is. That will at least give you some more information. Make sure maybe it's a salesperson or somebody who's talking to you, make sure they know their stuff and they're not mistakenly or purposely overstating that number and selling you a bike that you don't want. We want you to get your money's worth when you buy the bike and get all the power that you paid for. All right, so you know how much power the motor has, but how long can you use that power for? The third question you need to ask before getting an e-bike is, how much battery capacity does the battery on that e-bike have? So, to give you a little example, I'm gonna ask you another question. Check this out. This is the F3 Roadster. This is our 3rd generation of bike, and the battery, pull it out in 1 second. This is a 13.6 amp hour battery. This is from our 2nd generation of bikes. It's about the same size. It's a 17 amp hour battery. So which one has more capacity? The 13.6 amp hour battery or the 17 amp hour battery? I'll give you a second to figure that one out. So you know I fooled you last time. I tried to fool you again, but I hope you're smart enough not to fall into my trap. I only gave you half of the information. Battery capacity is not measured in amp hours, and it's also not measured in volts alone. This 2nd generation battery is 36 volts, and this one is 48 volts. So if you multiply those two numbers together, the amp hours and the volts, that's when you'll get the actual total battery capacity, and that number is measured in watt hours. Let me show you the equation. Battery capacity equals volts times amp hours, and that's measured in watt hours, or you'll see abbreviated WH. Look out for that. So this is our F2 2nd generation battery. I just told you it's 17 amp hours, but it's 36 volts. So if you multiply those together, you get the total energy capacity, which is 612 watt hours. So that's very important. The total energy capacity of this one, this is the upgraded battery, by the way, for the 3rd generation bike, the F3. This one is 13.6 amp hours, but it's at 48 volts, a higher voltage. Multiply them together and you get 650 watt hours. So it's actually more capacity than the 2nd generation battery. So you'll see these numbers a lot. You need to ask for that battery capacity in watt hours. Don't just ask for the voltage, don't just ask for that. You need both of these numbers multiplied together, or for short, just this single watt hours number. Now that's a lot of numbers. What does that actually mean for you? Let me put that in perspective. Let's go back to our world record holder, Bradley Wiggins, 2012 Tour de France champion. He set the record by riding for 1 hour at an average power of 410 watts. So you multiply these two together, 410 watts times 1 hour, that's 410 watt hours. So even if you got the basic standard 500 watt hour battery, you've already got more power than the world record holder right there. You'll also have your own leg power on top of that. So you're already in a really, really good place. If you're riding for an hour, you'll be smoking Bradley Wiggins here, Tour de France winner. So that's how battery capacity is measured. We do offer on our standard models, Roadster and Trail, 500 watt hours standard or 650 watt hours, which is an upgraded one. And you'll see kind of commonplace now for the electric bike industry is around the 400 to 500 watt hour mark. So keep an eye out for that. You need it in watt hours. And if whoever you're talking to you can't tell you that battery capacity, you need to run and get it from somewhere where they know where they're talking about. Number 4 question that you need to ask before getting an electric bike is what kind of brakes does it have? You've got all this motor power, all this energy in the battery, but if you're going really fast, hitting 28 miles per hour or maybe even 40 miles per hour on the blade, you really need to consider what you're gonna do when you wanna slow down to a safe, effective stop. So let's take a look real quick at the brakes here on this is the F3 Roadster. And all of our bikes use similar brakes. These are called hydraulic disc brakes. You'll notice they've got kind of a chamber up here and these hoses that go down to calipers and a disc here. So there's a piston in here, and what happens is when you squeeze the lever, it pushes hydraulic fluid on this piston and that grips the disc. And the advantage of that is that it is super effective. If you look at any modern car, especially fast cars, all of them use the same kind of system. They are hydraulic disc brakes, and there's a reason for that. They work very, very well. They're very powerful, very low maintenance, and very safe, especially when you're going at high speeds and you need to slow down quickly. So that's a hydraulic disc brake. and I'll show you some other type of brakes that you may see on an electric bike so you know what to look out for. This is just an older bike, and what you'll see here, these are V brakes, so it's not a disc brake. This is kind of a really old school style brake, especially for a mountain bike. But you see a cable in here, and if you listen to that handle, you'll hear a lot of like play. I've got to squeeze this down. Check out this handle on the right here. Look how far I've got to squeeze this, and it's really spongy. I'm not getting a lot of feedback here. I don't know when it's actually going to start braking. In fact, yeah. So that's a mechanical disc brake. So the disadvantage with this is there's many, but basically when I turn the cables, there's a cable inside of a hose here, and every time I turn it, it creates more or less friction. So the braking actually changes each time I turn it, or each time I ride the bike or move it. It's very sensitive, and they are famous, especially mechanical disc brakes, where you'll see a disc down here and the same kind of cable setup. Famous for being so finicky. I've cheaped out one time and bought a cheap mountain bike with disc brakes. This is before I knew anything about bikes. I was like, oh, it's got disc brakes, it must be good. But it was cable disc brakes, and they just sucked. I had to adjust them all the time. I could not get them right. It was a pain in the butt. I hated it. So they're very finicky, hard to adjust, hard to get right, and you have to make constant adjustments on it. Now, the hydraulic brakes, that is a complete system. So these are designed to be extremely low maintenance. Pretty much should never have to adjust these, with the exception of once you wear through the brake pads, you just change those out, but that's a huge advantage. The only reason you might want to go with a cable disc brake or cable V brakes is to save money. So that's a decision you'll have to make. When we first started this company, 3 generations of bikes ago, we looked at all the options, all the brakes we could find, and it was an absolute no-brainer for us. The cost difference between something crappy and cheap and something really nice that will actually be safe and stop you is only like 20 or 50 bucks. So for us, absolute no-brainer. It's our lives on the line. It's gonna be a nice performance feel. We went with the hydraulic disc brakes, and we've used that for every product that we've made. So you make your own decisions. You know, what do you value your life by? Would you like the mechanical or hydraulic disc brakes? You need to ask that question, and you can try out those tests too. So just a quick little test to see how effective these brakes are. We're gonna do a 1-finger challenge, 1 finger on the brakes, but I'm going to have my colleague Naomi come in and help with this. She's a little bit less muscular than me, so that will just show you even more how effective this is. 1 finger on that brake, please. Great. So that'll do a good job of stopping you. That's just one of Naomi's finger. You've got not 1, but 4 fingers to brake with if you really need some braking force. So that's that, and now I'll ask another colleague, Axel, to show you a quick video demonstrating his braking power. The next question also has to do with safety. I hope you guys picked the strong brakes. I hope you made the right decision there. But the next question also has to do with your safety and the quality of your ride. It is, what holds the wheel onto the bike? What is the mechanism that holds that on? And let me show you a bit more about that right now. So if you look at most bikes, most electric bikes on the market, and even our previous bikes, you'll see a similar system to this. This is called a quick release skewer. So how it is, this is locked in, I loosen it, and I pull out this little skewer, which kind of just holds the wheel in to this. This is kind of a wishbone thing here. So the fork is just resting on the axle of the wheel here. And the danger with that is, let's say my kids were playing with the bike or I was messing with it and I forgot to put this back on. I can be quite forgetful. Now I'm riding 20, 28 miles per hour, hit a little bump, and that is not gonna be fun. So we've actually seen this happen. Very sweet lady, made the same mistake, didn't put the skewer in correctly. Wheel came off when she went over curb. She went and landed on her face. That was no fun. I really hate to see that. And after that, we kind of revised it and thought, well, how can we make this better? There are better options available. Bike technology has come so far, so we look to mountain bikes where it's so important to have really beefy components. And this is what we use now on every model. Check this out. This is a 15 millimeter through axle. So these are called through axle because it goes through here, and this is the axle itself. Look how beefy that is. So with this through axle, even if I was stupid, and I do a lot of stupid things, I'll admit it. I was stupid and I forgot to tighten it. I've still got all of this material. This is like ½ an inch of solid aircraft grade aluminum holding this axle in place on both sides of the bike. So hopefully I would notice it before it kind of worked its way out, but this is gonna be way safer than any quick release system. It removes just as fast. I can unscrew this, pull it out if I want to take the wheel off. But also the major advantage of having this so big is you get a lot more lateral stability on the wheels. So we've got through axles both front and rear of every model here. Pretty sweet, and that gives you more stability, especially at higher speeds. Let me pull this out one more time for you. You need to ask yourself, all right, if I'm going 28 miles per hour, which one of these do I want holding my wheel on? So these are both, this is the through axle from the Trail, 15 millimeters, this from the Roadster, and this is probably what you'll find on most other bikes. It is cheaper. You will save a few bucks by going with this option. For us, we're definitely gonna pick this every time. So you make your own decisions. It's your safety again. When it comes down to brakes, through axles, we don't mess around. Hope you won't either. So I promised you 5 questions, but I'm actually gonna give you 6 because we like to under-promise and over-deliver. Question number 6, and I promise this is the last one, I know it's dragging on, is does the bike come with a warranty or not? And what are the details on that warranty? So you buy the bike and it is a machine. Sometimes things can happen, maybe a component will break. It is very rare, but they do happen, they are machines. I'm sure you've had something fail on your car before too. So does the manufacturer or the bike dealer you're getting it from offer a warranty, and what is that? You'll see a lot of folks online offering electric bicycles, but if you look further, they don't have any warranty at all, and in fact, they'll try and charge you, for example, for a $2,000 bike, $500 for a 1-year warranty. So you may save some money up front by not getting the warranty, but it could end up costing you a lot more in the long run. The reason is we make these bikes and we source all of the components ourselves directly from the factories. So we get the components at probably a third of what you can find them for online. So if you get the bike, something goes wrong, give us a call and we shoot you out a component. It's gonna cost us a lot less to service your bike, provide you that component, than if you had to buy it yourself. You'd probably end up spending a lot more than that to service it yourself. So make that decision for yourself. Do I wanna save money up front, or do I want something long lasting and covered by a comprehensive warranty? All right, that was the 5, or actually 6 questions that you need to ask before buying an electric bike. Has that been valuable to you? I hope it has. We put a lot of time, actually almost 5 years of my time researching these electric bikes, spending time in the factories, inspecting every single bike, going to the motor factory, and even the factory that makes the components for the motors, and checking every single detail on those to bring you the electric bike of our dreams. So you've got all the tools you need to find the right bike that fits you. And if you're anything like us and you just love these bikes, I've got a special offer for you today. I did tell you about the batteries, where we've got a 500 watt hour or a 650 watt hour battery, which is available for an extra $300, and it's our most popular battery. So today only, because you watched this presentation and educated yourself on what that battery capacity means, I know you'll appreciate this. We're gonna upgrade you to the 650 watt hour battery absolutely free of charge. That's a $300 upgrade that you're getting for free. So if you'd like the upgraded battery, now is the time to do it. Click this button and you can get it, that $300 upgrade value for free. So I hope this presentation has been valuable, and I hope to get you on one of these bikes or see you on maybe another e-bike. But enjoy, guys. Thanks for watching.